Hello, my name is Gavin Sacks, and I am professor and associate chair of the Department of Food Science at Cornell University. And in addition to that, I'm also the founder and current board member of the Ithaca Area Ultimate Alliance, a group dedicated to ultimate Frisbee, which I will not be talking about further, but you can go online and learn more about my favorite sport, ultimate, if you are unfamiliar. So food science, the textbook definition of food science will say that a food scientist is interested in improving both the food safety and the food quality of beverages and foods. That is, to try to limit the harm that a food can do to you, or to try to make the food more appealing, maybe better nutritional content, tastier, better looking. What food science is to me is whenever I go to a market or go to a grocery store and I look around and I see foods, everything from a bag of potato chips to a fresh apple, I know that a food scientist was involved at some point to make sure that that food is arriving to me looking good, tasting good, nutritional, and it won't harm me. There's not going to be microbial spoilage. There's not going to be dangerous chemicals. There's not going to be objects in the food. Whenever I'm at the market, I think there's a food scientist behind every item in this grocery store. So what made me want to pursue food science was I had a love of chemistry and a love of cooking. And I studied chemistry as both an undergraduate student and a graduate student. But a hobby, the background was always food, and not just food for the sake of cooking, but learning about food, reading about the science of food. And I thought this was going to be a hobby for me, that would be something I would do on the side while I pursued what I thought was a more typical career for a chemist in academia. And then I had an opportunity to apply for a job as a wine chemist, as part of a new enology, that is a study of wine, a new enology major that was going to be starting at Cornell. And I thought, well, maybe this doesn't just have to be a hobby after all. Maybe I can take my love of science and my love of food, and particularly my love of wine and other alcoholic beverages, and turn that into a career. So that's how I'm here. So my area of research is still chemistry, and more specifically, it's analytical chemistry. And more specific than that, it's analytical flavor chemistry. That is, what are the identities of the compounds in food that give rise to its flavor, particularly its aroma. That's my particular focus. And most of my work is on the aroma of alcoholic beverages like wines, but we do research on a number of other foods and beverages. We have collaborators who work on dairy products. We have collaborators who work on tomatoes, strawberries, other fresh fruits, who want to know what are the good smelling or not so good smelling things and new varieties they produce. We have collaborators who work on fish oil, other edible oils, and want to understand how to prevent off aromas from forming during storage. We have people who want to work on plant-based alternatives to detect either undesirable or desirable aromas in the products they're making. The joke that I have for my students is it's all the same periodic table. We don't have different compounds in different foods and beverages. Instead, it's more like an alphabet. We have different aromas arise by combinations of often the same chemicals, just in different concentrations. And so my research involves trying to figure out what those chemicals are and what combinations give rise to different sensations. And finally, what can we do if we wanted to influence it, either to get more variation in our foods or maybe to have less variation, depending on what your goal is. So my specific research right now, as an analytical chemist, the first thing I have to think about is how can I measure that? And odor active compounds, that is the compounds responsible for aroma, are such an interesting flavor challenge or analytical flavor challenge because of how low their concentrations are. These are some of the most potent compounds that we have in food. By potent, I mean have a biological effect. For something to have a taste, it usually needs to be present at percentage levels, maybe a little under 1%. For something to affect color, it usually needs to be present at a part per million level. That's pretty small, right? For it to have a toxic effect, it could be as low as a part per billion in some cases and still have a toxic effect for really toxic compounds. For odorants, you can have compounds that are present at a part per trillion or less, and they still have an effect on the aroma. Part per trillion. That's a drop of a compound in an Olympic-sized swimming pool. Going up and down, I just want a part per trillion on the way to the moon. So from an analytical perspective, this is such a wonderful challenge. And a lot of the work in our lab is trying to identify these trace level compounds, especially ones that are associated with not so good odors in products, and then find new methods, especially really quick, easy methods to measure these compounds so that we can do it routinely as a way to screen products, to do quality control. Because you don't want to have a situation where you know what's causing a problem, but then have no easy way to measure that problem. If you're trying to make a lot of a food that you're going to put into a grocery store, you can't have someone smell every individual package to make sure it smells okay. What do I want to see in food science over the next 10 years? What's come out of the last decade or so is increasingly good sensors, ways to collect data about systems, ways to make measurements. The hard part still is knowing what to do with this information. How do we use it to make good decisions? And not just decisions about do we have a problem, but sometimes the decision-making process for food science is knowing that there is no problem. We don't have to stop. We can keep doing what we're doing, keep production happening, not throw away that food, even though it looks a little bit out of specifications. What I'd love to see happening more with the data that's coming online is improving our efficient decision-making processes for food, and especially for when a food is going to be acceptable or unacceptable to a consumer. We have pretty crude measurements right now for determining whether that something is going to be unacceptable or really time-consuming ones involving people smelling things or taking a look at a Best By date and throwing it away. What I'm hoping over the coming decade or so happens is we get better and better at having convenient ways to decide if a food is outside of specification, spoiled, potentially dangerous, just doesn't taste or smell right. But even better than that, knowing when it's not outside of specification. That is, that food that we thought might have been past the Best By date, it's just fine. And we can keep it in the food supply. Piece of advice I'd like to give to students who are thinking about a career in food science. Remember, there's two parts to that. There's food and there's science. You need to have a rock solid background in sciences to be an effective food scientist. This is going to be a good background in chemistry, a good background in microbiology, a good background in general biology, strong knowledge of math, being competent at calculus and statistics. All those core disciplines are going to be important. But at the end of the day, it's about food. And I say this as someone who works on food flavor. Doesn't matter how nutritious that food is, doesn't matter how safe that food is. If that food doesn't taste good, you don't have to worry about safety, don't have to worry about nutrition. No one's going to eat it. So make a lot of food, eat a lot of food, do experiments, try new things, pay attention to what changes when you try new things. See if you can relate that core knowledge that you have in science to what you're observing when you prepare or experience food, because that's what you're going to be doing as a food scientist if you pursue it here for study at Cornell or elsewhere, or eventually follow a career into food science.